right, guys. So right here, what I'm going to go ahead and do is I'm going to do the warm up here. One thing I can't emphasize enough is read the directions. It tells me right here that I need to determine the number of solutions between 0 and 2 pi. It's not saying I need to solve the equation. So what I have here is I have this cosine 4x. So when I have something like that, I have to remember that that's what we have for our multiple angles. And what that 4 has done to my equation is it's done a phase shift. And that 4 itself, remember that it's going to be on the inside of your parentheses. That's your B value. And that changes your period by the reciprocal of the number that you see. So I'm seeing 4 here. So that's going to make my period no longer be 2 pi. But really what it's doing is it's making it be 2 pi over 4, which is pi over 2. So now what I've done is I've compressed my graph. I've compressed it by 1/4. So now what I originally had when I had my graph, when I had my, I keep trying to draw a sign, it's cosine. What I have right here for this graph is that would be my cosine from 0 to 2 pi, but it's no longer to 2 pi. Now it's to pi over 2. And so what I have instead now, if it's going from between 0 to 2 pi, well, how many half pies do I have? I have 4 of them. So this is going to keep going like this, and then it's going to do it again, and then it's going to do it again. And you're going to have 4 of those between 0 and 2 pi. And so what I'm going to have here for this particular equation, if I'm to go ahead and solve this, I'm going to have cosine 4x is equal to 0. So what I need to do here is I need to figure out how many times does cosine equal 0 between 0 and 2 pi? Well, cosine equals 0 between 0 and 2 pi twice. That's at pi over 2 and 3 pi over 2. So at those points in time, I'm going to have a solution for my equation. Now, since this has been compressed by 1/4 and it's going from 0 to 2 pi, I have 4 solutions. So it will be every single time that cosine equals 0 throughout the entire period. So whenever you have something, like I said the other day, when you have something with this multiple angle in there, you have to remember that that is compressing or stretching your equation by the factor of what you have there, the reciprocal of that. So if I compress it, then my solutions are going to be most likely equivalent to what I have in this number here times 2. So since this is 4x, it's going to be 8 solutions. The time that it wouldn't be equal to twice that number would be, for example, if you had something that ends up being sine when it's equal to 1, or cosine when it's equal to 1, or -1 for both of those as well. Just because that only happens once for each function. So just keep that in mind as you're going through these. So what I have here on this equation is my solution for this one. The number of solutions I'm going to have would be 8. Okay. Now, let's see. All right, now for this one, if I was to go ahead and solve this, I've got to get the tangent 2x by itself. So I'm going to divide both sides by -3. So when I divide both sides by -3, I end up with tangent 2x is equal to square root 3 over 3. So now between 0 and 2 pi, how many times does tangent equal square root 3 over 3? It's going to equal square root 3 over 3 because it's positive. It's going to go ahead and equal that twice. and that's going to be at pi over 6 and 7 pi over 6. Again, I don't need to actually solve this, but I'm just kind of thinking this through a little bit here. If it's at pi over 6 and 7 pi over 6, then if I've taken my entire graph and I have compressed it right here, like I have on this case, that means that I've taken my graph and I've shrunk it down, or 1/2 of the period. So what I've got here, once I've done this, is I'm going to go ahead and graph it, so you can kind of get the visual that I'm going for here. Remember that tangent went like this, right? But right here in the middle was 0, okay? And I had my asymptotes here at pi over 2 and negative pi over 2. So my period itself was just pi, okay? Now I've taken that, I've shrunk it in half, so that means that my asymptotes are going to be at pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, and it's going to keep going. All of my pi over 4s are going to end up being my asymptotes instead of my pi over 2s. And again, the reason I know that is because I've compressed my graph in 1/2. Half of 1/2 is 1/4. So basically what I'm going to end up doing is squishing both of these this way by 1/4. And so now all of my asymptotes are going to be at pi over 4. So what I'm looking at here is I'm considering when this is going to equal square root 3 over 3. And in each period, this only happens one time. And so what I've got right here is it's going to be square root 3 over 3. If I actually did solve that and do all of it as I should, then that would be pi over 6, where it equals that. And again, that only happens once in each period at pi over 6. And so if it's happening once a period, and I'm thinking about how this is going to end up going as I go down here, if my asymptote is now at pi over 4, let me go ahead and write that in here. So I'm going to have that at pi over 4 now. That means then my next one will be at 3 pi over 4, and then 5 pi over 4, then 7 pi over 4, and then I'm going to end up getting to 2 pi, and I'm going to go beyond that really quick here, and I'm just going to say 9 pi over 4. And so if I've gone to 9 pi over 4, obviously I'm outside of my domain of my function, but I can at least see here, okay, if I have all of these are asymptotes, and then I have this tangent graph continuing each time, doing the exact same thing over and over and over, how many times is that going to equal square root 3 over 3? That's going to equal that 1, 2, 3, 4 times, and only 4 times. It's not going to happen over here on this one because at 0 right here, I should say 0 for my y, it's not 0 on my x, but that's 2 pi. 2 pi right there will be at the 0, so it's not going to get to the positive part of that here. So I have 4. So it does work out in this case that it's going to end up being 2 times the amount of solutions that I have between 0 and 2 pi. And so square root 3 over 3 for tangent happens twice between 0 and 2 pi. So what I've got here is between 0 to 2 pi, when it's equaling square root 3 over 3 twice, that's what it's going to end up doing for my next one, but it's going to happen 4 times because it's happening twice per period, and now I've shrunk that period in half. So now it's doubling my amount of solutions. So now I have 4 solutions in this case. All right, so let's go ahead and look at this one. So for this one right here, what I have is I have square root of 3 equals 2 sine x plus 3 pi over 2. I don't have a phase shift in this one, yay. However, I shouldn't say I don't have a phase shift. I have a period change. I think I said phase shift earlier for something. Sorry. B is a period change, not a phase shift. I think I said that earlier. Either way. So what I've got right here is it's moving my graph left 3 pi over 2. So what I'm going to end up doing here is my graph for sine normally goes from 0 to 2 pi. It still is going to have a period of 2 pi. It's just moved left 3 pi over 2, which is actually 3/4 of your entire unit circle. So that's a pretty large shift left. So basically what I'm going to have here is for my sine, it's now going to do this like it always did, but instead of going from 0 to 2 pi, I'm going to be starting here at negative 3 pi over 2. And then instead of going to 2 pi, I'm now instead going to be doing, well, I'm still going that distance. I'm just not going to actually finish there. Instead, I'm going to finish at pi over 2. And so then I would have my next round to go on my value here. And I would have my solutions would be up here. I would have 2 solutions, and that would be when sine is equal to square root 3 over 2. And I'm getting that from just dividing both sides by 2 here. Sine is going to equal square root 3 over 2 twice on my unit circle between 0 and 2 pi. And so what I'm going to end up doing here, and actually this one would be 0 and 2 pi would be over here. And so that's how I know that I've only got 2 solutions in this case, because without shifting my graph, I would have had 2 solutions. All I did was shift my graph left, and it's not going to change the amount of solutions I have. All I did was just move it left. If I moved it further left, I would still have 2 solutions, because then that just means that I would now have instead another part of the graph would come in. So if this part goes left, so does this part. Likewise, if this part goes right, so does this part. And then I'd have another graph coming in from over here on the left side. So it's just a matter of if I'm shifting my graph left or right, I'm not changing the amount of solutions I would have had. I'm just changing where they're at on my x-axis. That's it. And so here I did not change my period, so I'm going to have 2 solutions because that's what I would have had whether I shifted it left or right. We just don't know where they're at right at this point in time. All right, and so since I'm a cheapie, I'm not paying in order to actually make these recordings, so I'm almost at my max time that I can do for one, so I'll make another one.